This is the second part of chapter 2, and now we're going to talk about present value. So future value is very intuitive, right? We deposit our money today, we're going to have a specific amount of money in the future. Now, present value is exactly the opposite. Think about, I need $1,000 in 1 year. How much money do I need to deposit today so that I can earn some interest, and at the end of 1 year I'm going to have $1,000, right? So we were talking about compounding, that's building interest on interest. The opposite, it's called discounting, and this is what we're going to be doing with present value. So the value of an investment today, it's equal to the present value of its future value, right? So we have whatever we're going to be receiving in 1 year, we divide by 1 plus I, and that's that way we get our present value. We can also do this with our calculator. So again, if a bank pays $105 in 1 year and our interest rate is 5%, same example as before, right? Same example as before. We receive $105, we divide by 1 plus our interest rate. Every time we use a formula, by the way, interest rates need to be expressed as decimals. So 105 divided by 1.05, it's going to be equal to $100, right? Again, that's, in a nutshell, that's the formula, right? Present value, it's equal to future value in 1 year divided by 1 plus I. Now, if we are going to be doing more than 1 year, we're going to be elevating to the exponent of the number of years, right? If we go back here, we can change this to the future value at year n, and then 1 plus I elevated to the nth power. Now that's FYI, we can use the calculator, right? And I'm actually expecting you to use the calculator all the time because it's faster and you know where everything's coming from, right? I don't want you the calculator to be a black box. I want it to be a tool to make things faster, but you should be knowing where your information is coming from. Now, first things first, second function, clear time value of money, right? We want to get rid of the information we had from our previous problem. Now we know that we are going to be receiving $100 in 5 years, and the interest rate is 5%, right? How much money do we have today? We receive $100 in 5 years, and the interest rate is 5%. So we know n is going to be 5, right? 5 years, right? Interest rate, it's going to be 5%. We don't know present value. Right? We want to know how much is this equivalent today. We disregard payment, and we know that we're going to be receiving $100, right? Basically, we want to know how much money do I need to put in the bank today so that I can have $100 in 5 years, assuming my interest rate is 5%. So we go here and we click 5 and then n, right? Then another 5 and I over y, 0 and payment, 100 future value, right? Just compute and PV. Okay, same number as in here, right? Why negative? Well, we're assuming that we're going to be receiving $100 in the future, right? In order for us to receive money, we need to put in money. Therefore, the present value is going to be negative because it's a money outflow. Future value is positive because it's an inflow. Now, in very strict terms, it doesn't really matter which one is positive, which one is negative, as long as one of them is positive and the other one is negative. If you make them both positive or both negative, your formula and your calculations are not going to work. So make sure you're aware of that. So you can discount using different interest rates per period. You basically multiply times 1 plus the interest rate of every period, right? So yes, I mean, you receive $2,500 in 3 years. You have 7%, 8%, 8.5% per year. You just multiply all of the rates in the denominator and make the calculation, right? It's pretty straightforward, right? So if we want to move our cash flows from 1 year to the other year, we can use compounding, we can use discounting. Don't forget, compounding is for us to find future values, right? How much are we going to have in the future? Discounting is how much are we going to be having today, right? So, for example, we expect to receive $200 in 3 years. And now change the receive of cash flow to 2 years. What if we want to receive our money 1 year earlier? Let's say the discount rate is 6%. Now, here we have the calculation. Let's do it with our calculator, right? So we say, okay, what if instead of receiving $200 in 3 years, we want to receive an X amount of money in 2 years? How much are we going to be settling for? Well, we know that N is going to be equal to 1, right? We're moving it from 3 years to 1 year. Therefore, we want to know the equivalent in 1 year, right? The discount rate, it's given as a 6% rate, right? And we know that we don't have this, and $200 is the amount we expect to receive. We're going to compute present value, and this is the same as this, right? 188.68. That is, if the interest rate is 6%, you are indifferent between receiving 188.68 on year 2 or 200 in year 3. Why? Because if you receive 188.68 on year 2 and you invested at a 6% rate for 1 year, you should be having $200 by the end of year number 3. That's your breaking point, right? Now, if for some reason I tell you, okay, would you settle for 195 in year 2? Well, you know that that's not a good business. Well, that probably might be a good deal for you, right? If I give you 195, well, you can put it in the bank for 1 year, and you're certainly gonna make more than $200, right? What if I give you $150? Well, you put it in the bank for 1 year at 6%, you're not gonna make 200. So this is the importance of these calculations, right? Same here, right? Gonna clear time value of money. We expect to receive $200 in 3 years. Now, what if we wait till 5 years, right? So we're moving from year 3 to year 5. We are gonna wait for 2 more years, and we're receiving 6%, right? And we know that we have $200, and we're not dealing with this. So if we let our $200 sit for 2 more years, and assuming we receive a 6% return, we're going to have $224.72 by the end